So this video is going to talk about features of functions, which is going to go on page 3. And if you have some different colored utensils to write with, like colored pencils or markers or different colored pens, I would suggest having those with you while we work through this lesson together. So what we're going to do is on the left-hand side of your paper that I gave you, you're going to see some vocabulary terms, and we're going to talk about those vocabulary terms as we look at this graph. What I do want to show you before we get started with the graph itself is the difference between a continuous graph, a discontinuous graph, and a discrete graph. So if a graph is continuous, it will always be connected. If I was going to trace a continuous graph, I would never have to pick up my pencil. So an example of a continuous graph would be something like this. This is a continuous function because as I trace it with my pen, I am always touching the function. I never have to pick up my pen to continue on to a new part of the function. However, if a graph or a function is discontinuous, there will be portions where I can trace it. But then in order to continue to the next part of the function, I have to pick up my pen and then keep tracing. So this is discontinuous because of this portion right here where the two functions are not connected. This is what makes it discontinuous. And lastly, if a graph is discrete, there are no lines at all, and it will be a variety of points. Some people call this a scatter plot, and that's fine. You can think of it as a scatter plot, but if it's just a bunch of points, then it will be a discrete graph. And again, just a reminder, if I'm going to look at whether or not this discrete graph is a function, I need to check and make sure that at any point in time for an input value, there is only one output that matches up. So there shouldn't be any points that stack on top of each other, so to speak. So for example, if there was a point here and they would share that same input value, that discrete graph would no longer be a function. So as long as that point's not there, we have a function. So we're going to go ahead and start looking at our graph, and we're going to start talking about some of these key features or important pieces of information. We're going to start with maximums. There are two types of maximums. You could look at an absolute maximum or a relative maximum. An absolute maximum is the highest point on the graph in comparison to every other point there could be. So hopefully you had enough think time for that. This point right here is the absolute highest point on the graph. So this is our absolute maximum. And we write our absolute maximums or any coordinate point on a function or a graph as a point. Our input value will go first. Our output value will go second. So my input value for this is 250. and my output value is 110. So that's how I would write the coordinate point for that absolute maximum. Now I could also have a relative maximum. And for a point to be a relative maximum, it needs to be the highest point in that general area. And to the left and to the right of that point, all of the parts of the function or points around it should be below. So this point right here, since the graph to the left and to the right is both below that point, this is a relative maximum. And we still write our coordinate the same way. However, in this case, our tick mark doesn't show up on a tick mark that's labeled. It shows up right here. So I need to go back to the origin, or where my graph starts at 0, and figure out what that input value here would be. Well, there are 1, 2, 3, 4, 5 tick marks that take me up to 250. So if I count by what number, it would take me 5 jumps of that number to get to 250. Well, it would be 50. 50, 100, 150, 200, 250. So I know that every tick mark along the way is a value of 50. So since here I land on this tick mark, I am 50 above 750. So I know that my input here is 800. My output value here is 90. If it's hard for you to see with this graph where points are lining up, one thing you can do is use a ruler to help you see horizontally or vertically where your coordinate points are lining up. So that is our maximums. Now we're going to do the same thing looking at minimums. So an absolute minimum will be the lowest point or points that we can get to on our graph. So as I'm looking at my graph, you'll notice that along this y value of 10, there are 2 different points that have a y value of 10. This tells me I have 2 absolute minimums. They both happen with a y value of 10, so it's okay that I have 2 absolute minimums. So this absolute minimum has an input value of 1,250 and an output value of 10. This absolute minimum, and I'm going to abbreviate just because I don't have a ton of space, is an input value of 0 and an output value of 10. And again, they're absolute because they are the lowest points on the graph. A relative minimum will be the lowest point in relationship to the graph to the left and the right of that point. This point here is not considered an absolute minimum because if I look at the graph to the right, it's still going lower than where I am at that point. So this will be our only relative minimum. And that coordinate is, I am 1 tick mark over, so this is 550 and 30. So that's it for our maximums and our minimums. The next thing we're going to look at is our increasing and decreasing intervals. So increasing means as I travel from left to right along the graph, if I'm increasing, that means I'm going up. And if I'm decreasing, that means I'm going down. So first thing I'm doing along my graph is going up. So this would be an increasing portion of my graph. Once I get to this absolute maximum and I'm at my highest point, now I actually start going down. So this is not called increasing, this is called decreasing. So I've gone up to my absolute maximum, I've come down to my relative minimum. Now I'm going to look at what happens after I start to leave my relative minimum and travel to the right. Well, now I'm going back up to my relative maximum, so this portion is increasing. And now, from my relative maximum all the way down to my absolute minimum, we are decreasing. Even though I turn and go a different way of decreasing, all of this is still a decreasing interval. I'm going to grab some more colors. I didn't get enough. The next thing we're going to talk about is domain and range. Domain is all of the possible input values we could see, and range is all of the possible output values we could see. And we're actually going to start writing our domain and our range, but we're going to do that in words. So my input values are here along the bottom, which coincide with the distance that we are traveling along this roller coaster track. So all of these values down here fall in our domain. So if you look down to the third question, it says, what is the domain of this graph and what does it represent in this scenario? So if I want to look at our domain, I want to go all the way to the left, to the farthest spot where my graph is living. And since this is a continuous graph, I'm going to go to the starting point, which happens at 0. So my domain is going from 0 feet to, and now I have to come back here and I need to go all the way to the left and look at, or excuse me, to the right. So I've gone all the way to the left and looked at that farthest spot. Now I've gone all the way to the right. My highest value for domain is 1,250 feet. And this represents the distance that we are traveling along the track. Now we are going to do the exact same thing for range, but instead of going side to side like we did for domain, we're going to go up and down. As long as your graph is continuous, you are going to look at your absolute minimum value. So So I'm going to start here. I'm going to turn my graph sideways so I can write the word range. I'm going to do it the other way so it goes the same way as the words. Okay, so now we're doing range. So I go from my absolute minimum value, as long as it is a continuous graph, and I'm looking at all of the output values that are possible. So I'm going from the bottom, if I could get the ruler straight, all the way. I still have graph, I still have graph, I still have graph, there's still graph here, until I get to the absolute maximum, and that tells me the highest point that I'm going to see on my graph. So that tells me the largest range value. So I went from a y value of 10 all the way up to a y value of 110. So I'm going to go down to the very last question, and my range goes from, not 0 feet, 10 feet to 110 feet. And if I go back and look at my graph, what this represents is the height above the ground. So our range tells us how high above the ground the roller coaster car is. So our domain, our input values, tell us how far we have traveled along the track of our roller coaster. And our range values tell us how high above the ground we are. The last thing we need to talk about are intercepts. So we're going to start with the y-intercept because that is our first question. The y-intercept happens when the graph or my function hits the y-axis. So I'm going to come to where I see my range values, my output values, and I'm going to look up and down and find the place where my graph touches the y-axis, which also happens to be my absolute minimum. So this is also called a y-intercept, and I'm going to abbreviate just because I don't have enough room. So my y-intercept is the point 0, 10. And I have to figure out what this means in my scenario. Well, my domain value tells me how far along the track I've traveled. So I have gone 0 feet. This tells me we are at the start of the roller coaster. And we are 10 feet above the ground. And since we are talking about intercepts, we're also going to go to the question about x-intercepts. Now there are no x-intercepts. If I look along the x-axis or the domain values, there is no place where my graph touches this horizontal axis. Now we're talking about a roller coaster. If I'm on a roller coaster, let's look at this piece here. If I'm on a roller coaster, yes, my horizontal axis represents how far along the track I've traveled, but my y value, if I'm on this horizontal axis here, my y value would be 0. My y value represents how high above the ground I am. If I'm on a roller coaster and I am no feet above the ground, that that means I am on the ground. I do not want to hit the ground when I am on a roller coaster. So there are no x-intercepts because the coaster is not going to hit the ground. That would not be a very safe roller coaster. So now we're going to talk about our absolute maximum. So our absolute maximum happens at 250, 110. We talked about that earlier up here. And in terms of what that means for our roller coaster, it is our highest point of the roller coaster. Before we do our first fall. Or goes down. All right, last but not least, we're going to start learning how to write an increasing interval. We are going to write this in words today, and then tomorrow we are going to start learning how to write this with inequality symbols. So, our increasing intervals are written using our input or our domain values along where our graph is going up. So here's how I like to start doing this. My increasing function begins at a minimum, and it's going to increase until I get to some type of maximum. So I like to just draw myself imaginary vertical lines along where these increasing portions are happening. So the first one starts happening when my input is 0, and it increases this whole time until I get to 250. Then I get to my maximum. So my first one is from 0 feet to 250 feet. And I have a second one that starts at my relative minimum at 550 feet, and it's going to go all the way until I get to my relative maximum at 800 feet. So this whole chunk of time, I am increasing. So it started at 550 feet, and it went to 800 feet. And what that means for my roller coaster is that the coaster car is going up. You could say it's climbing. However you want to say it, it's going up on the track. So that is an overview of the vocabulary terms that we had on the left-hand side of our page. The only one we did not talk about was a constant interval. And the reason we didn't talk about a constant interval is because there is no point in time in our roller coaster where we are just moving sideways and not changing our height. So a constant interval is just going to be a horizontal line that does not change its y value. So now that you have completed the lesson, you can go ahead and work on the activity that is shared with you on Canvas.